Let us look at matrices. Now we have seen simultaneous linear equations. So let's look at an example. 4x plus 3y equal to 5 and x plus 6y equal to 2. So we have a simultaneous linear equation and we have to figure out what the values of x and y should be for both these equations to be satisfied. So we multiply the second equation by 4 so that we end up with 4x plus 3y equal to 5 and 4x plus 24y equal to 8. Now subtracting these two, we get 4x gets cancelled. 3y minus 24y is minus 21y. 5 minus 8 is minus 3. And y is equal to minus 3 by minus 21, which is equal to 1 by 7. Now, we substitute y in any one of these two equations. So 4x plus 3 times y, that is 1 by 7, equal to 5. And solving for x, we get x equal to 8 by 7. Now, in the above example, we are manipulating the entire equations. Remember, we are multiplying the second equation by 4. Then we are subtracting the equations. So we can write this in this form. We have 4, 3 bar 5, 4, 3 bar 5, 1, 6 bar 2, and we do the same operations. Our operation becomes 4, 3 bar 5 minus 4 times 1, 6 bar 2. And simplifying that, we get 4, 3 bar 5 minus 4, 24 bar 8. Each equation has 3 parts: coefficients of x and y and a constant. So coefficient of x is 4 minus 4, which is equal to 0. Coefficients of y is 3 minus 24, which is equal to minus 21. And constants 5 minus 8 equal to minus 3. We get 0, minus 21 bar minus 3. Now converting this back into an equation, we get minus 21y equal to minus 3 because x coefficient will be 0, which implies y is equal to 1 by 7. And substituting it, we get x equal to 8 by 7. So whether we use this method or this method, we get the same result. Now that this way of doing it and this way of doing it gives us the same result, but we actually do it in a different way. So we write the coefficients of x and y in the form of rows and columns within a bracket. So we have 4, 3, 1, 6. That becomes one of our grouping. And then we have these two variables, x and y. So that becomes another grouping. And the constants 5 and 2 becomes another grouping. So our system of linear equation becomes 4, 3, 1, 6 times x, y equal to 5, 2. So this way of grouping the elements or grouping the coefficients and the constants and the variables, we call this form as matrix. So we have a matrix times another matrix equal to another matrix. So here, the first matrix contains the coefficients, the second variables, and the third contains the constants. Just try to map the coefficients, the variables, and the constants in this form. A matrix is a rectangular arrangement of elements in rows and columns. So, for example, let's say A is equal to a matrix where the elements are 1, 2, 3, 2, 3, 4, and 3, 7, 1, organized in rows and columns. Let's say there is another matrix B is equal to x1, y1, x2, y2, x3, y3. And another one, B is equal to f sub 1 of x, f sub 2 of x, f3 of x, and so on. So here you will notice that in this matrix, we have numbers. In this matrix, we have variables. And in this matrix, we have functions which take a parameter x and give us a value. So for a specific value of x, we get a matrix. Now, matrices form a fundamental part of linear algebra. These matrices are referred to as matrices of order A sub 3 by 3, B sub 3 by 2, P sub 4 by 3. So what does that 3 by 3 means? It means 3 rows by 3 columns. So 3 rows by 3 columns. B is 3 rows by 2 columns. And P is 4 rows by 3 columns. So in general, if we have a matrix Q sub M by N, denotes a matrix with M rows and N columns. Each entry in the matrix is called an element of the matrix. So here 1, 2, 3, 2, 3, 4, 3, 7, 1, x1, y1, and so on, f sub 1 x, f sub 5 of x. These are all elements of the matrix. The elements of a matrix are denoted using the same letter as the matrix name in lowercase with subscripts. So A sub 23, actually we should read it as A sub 23. That is the element in the matrix A in the second row, third column. So second row is this and third column is 4. So A sub 23 is equal to 4, where 2 is the row number and 3 the column number. B sub 31 is equal to row 3 and column 1, that is x sub 3. P sub 42 is fourth row, second column, that is f sub 11 of x. So that is how we refer. Remember here the matrix name will be denoted by a capital alphabet and its elements will be referred to using lowercase same alphabet. So in general, for matrices A, B, P of order M by N, A sub I, J, B sub I, J, P sub I, J refers to various elements depending on the values of I and J. And here I will be from 1 to M and J will be from 1 to N. The elements of a matrix can be real numbers, complex numbers, or function values in real or complex. So that was introduction to matrices. In the next session onwards, we are going to keep going into more and more detail. That's it for now.